we are going to jump right into finding areas under curves. Should have checked it. Ah, the camera's working, good. Well, essentially, what we do is that you start with some curve. We'll call it y equals f of x, keep it nice and general. And you're starting at some value of x, let's call it a, and you're finishing over here at some value of x. We'll call that b, so you're finding the area under the curve from x equals a to x equals b. And the way in which we're going to get an estimate of that is simply by just splitting it into, let's say, in this case, 4 strips. To remind you, n equals 4 means 4 strips. And then for these strips, we have 2 main strategies. For any given strip, we can either use the left-hand side or the right-hand side to be the height of the rectangle that's going to represent that strip. So if we decide, for no particular reason, because I want to do that one, then on the next strip, we have to use the right-hand side. And in this strip, you have to use the right-hand side. And then in the last strip, you use the right-hand side. And these 4 rectangles, we calculate their area and we add them all up. And that would be our estimate. A few other things to remind you. We have a guy called delta x, which is that distance there, the width of the strip. And delta x is calculated by subtracting the start and finish and dividing by how many strips. And then when I do my estimate, what I would do is delta x times this guy's height, delta x times this one, delta x times this one, and delta x times this one. So what we're going to try and do here is generalize it. So there's not a number in sight, or at least as far as we can do it. So I have my little table. Now, since I am choosing the right-hand side, this estimate is going to be called R4, right? If I used the left-hand side, I would call it L4. And it would start at A. That would be the guy there. Now it gets a little bit trickier. What would be the x coordinate of this fella? Well, it'd be A plus a delta x. And then this one would be an A plus what? What would that one be called? This one is A plus delta x. What would that one be?
Would it be A plus 2 times delta x?
Yes. And then this one would be A plus 3 delta x. And right at the end, it's B. Yeah. Now I've virtually generalized that as much as any person would want to. And so the value of the function would be that. It would be that. It would be that one. Well, it would be that one. And I guess we do that guy at the end. And then I would multiply the delta x by the height, the delta x by the height, the delta x by the height, and delta x by height. And that's really kind of the way I've set this up. If I told you A and B, and I told you what the function is, wouldn't all these things turn into numbers that you could use? So I've just basically tried to generalize the whole process. And no, I'm trying to add not one person. Let's work on numbers. Suppose I have a function starts at A, finishes at B. And for this function, do you notice that it's increasing? That's important. So I'm giving you a little property here. If a function is increasing, in the interval AB. Here's the cool thing. Let's just pretend that there were 4 strips again. If a function is increasing in a certain interval, as it is in this diagram, if I calculated L4, right, that means I'm using the left-hand side of these rectangles. So in this case, it would be these rectangles. And you see the L4 is what we call an underestimate. It means it's less than the real answer. Would you agree that these 4 rectangles add up to an area that's less than the area under that curve? So L4 is an underestimate. I don't think it takes much to come up with the idea that if I then do the other version, which is these ones using the right-hand side, can you see that is an overestimate? So if I have an increasing function, won't L4 be an underestimate and R4 be an overestimate? And so we can say this. Isn't the true value of the area under the curve somewhere between the left 4 and the right 4 estimates? Does the logic of that make sense? Right. So if you use L4, you get an answer that's less than the right one. If you use R4 to do it, you get an answer that's bigger than the true answer. So the true answer is between them. So we're going to spend most of our time dealing with curves that are always increasing or always decreasing. And these underestimates and overestimates are the most common name, but sometimes you might see terms like smallest estimate and larger estimate, yeah, which is just a different way of saying under and over. For completeness sake, suppose I have a function that's decreasing. Just imagine I don't know, 3 strips just to be different. Here we go. If a function is decreasing in the interval A to B, then will L4 still be an underestimate and will R4 still be an overestimate in this new situation? What do you think?
Won't it be the opposite?
It will. I'll just show you. Let's do an L4, right? For each strip, choose the left-hand side. So if I was using an L4, wouldn't our answer be these big green ones, right? Can you see how they're overestimates? Right? These rectangles have an area that's more than the curves. So L4 is an overestimate. And R4 is an underestimate. So what this tells us is that as long as the function's increasing or decreasing in the interval that we're interested in finding the area, we can find the L4 and the R4. And what that will do is it will give us a kind of tolerance, I guess, if I'm using an engineer's term, that the real answer is somewhere between here and here, right? Now, here and here, meaning left 4 and right 4, might be quite big, which means that there's a lot of space for the real answer to live. But we've also noticed that if you do more strips, don't you get more accurate answers, no matter left or right or whatever you do? So can you imagine if you did it with 10 strips, it would be in this kind of range, right, between here and here. And 1,000,000 strips, it would be between an atom here and an atom here, right? The number you'd get, you couldn't tell the difference between them. So now you have a way of getting as accurate as you want the area under a curve. Now, human beings, me in particular, but I'm sure most of you, do not want to do 1,000,000 of these. So when it comes to something extremely big, all we do is we have computer programs that do it for us. So you would just plug it into a computer and say, do a couple of billion strips, and boom, it would come out with the two estimates, and you'd look at them and say, they look like they're the same number. That must be the area under the curve then. Or at least to 20 decimal places, there's the same number, which means you know the answer to 20 decimal places. So, the questions I'm going to do after this one is ones that involve graphs. But the problem with the questions when they involve graphs is that you have to read off the answer. And I'm not very accurate at doing that. So I want to show you a function one where we can do the values, and then we'll move over to these less than stellar ones. So let's suppose that I am interested in finding, what will I find? I want to find an increasing function. So let's do this guy. Suppose I want to find the area of y equals x cubed plus 1. And I want it to do it from 2 to 4, right? So the question was, find the area under this curve from x equals 2 to x equals 4. I'm going to pick 4 strips. Let's say that's part of the question. And let's say the question also says to find these two guys. Okay, so find an underestimate and find an overestimate might be the way they'd phrase it. They might phrase it by saying, find a big estimate, find a small estimate. They might phrase it by just saying, find L4 and R4, right? They're still asking you to do it. They're just telling you in different ways. Right, so can you imagine 1, 2, 3, 4? What you would do, I suggest, is that you set up a table. And you know the first number is 2. And then you find delta x. In a case like this, you could probably do in your head. Would you agree that delta x is going to be 0.5? But let's pretend it's 8 strips or 7 strips or 6 strips. It's just helpful if you've got a calculation. So the calculation is that, remember? And that's A, and this is B. So it's going to be 4 take away 2 divided by that, and we get 0.5. And that allows me to go 2.5, 3, 3.5, and finally 4. Now, this is something I didn't do yesterday, so I'm going to introduce it now. Is some more notation. The first x, the starting value of x, is called x0. This guy is called x1. This guy is called x2. This guy is called x3, and this guy at the end is called x4. So if someone went and said to you, what's the coordinate for the value for x2, it would be 3. The coordinate at the end would be 4, x0. Okay with that way of naming the x coordinates? So you can imagine you did 10 strips, right? N was 10. You have a table starting at x0, 1, 2, 3, 4, 5, 6, and finishing at x10. That's actually quite helpful because if you want to describe, as I will in a few minutes, what the calculation looks like in a very general way, it's helpful to call it these guys. It's much clunkier if I have to call it these guys. Would you agree these are quite awkward looking things to deal with? And it's kind of cleaner just to have little numbers. And that's kind of the reason behind it. Now, this guy comes into play. Because I do not want to calculate x cubed plus 1 5 or 6 different times. I could do it, it's not that onerous, but I'm lazy. Plus I'm not very accurate, so press y equals. Type in what the function is if you know it. In this case we do. That's that done. Do second table setup. Start at the first value, which is 2. Delta x is 0.5, so that's what delta table represents. Make sure the other two say auto. And now I'm good to go. Second table. And the answers are 9, 16.625, 28, 43.875, and finish with 65. We're comfortable with this? I mean, it's more laborious than difficult, right? We got all the numbers. Now, wouldn't it be nice to actually get our first fella? Now, L4, right? So you're using the left-hand side. I guess L4 would be these guys here. Can we see just visually that L4 is definitely an underestimate, which we could have figured out because of what I said earlier, increasing function. L4 is an underestimate. If I wanted to write this down in a very general sort of a way, it would look like this. You would be using these 4 guys, right? The 4, right? The 4 on the left. If we did them as numbers, which I will in a minute, but let's not do them as numbers. The first rectangle would be delta x times the value of the function at x0 plus delta x, the value of the function at x1, plus delta x, the value of the function at x2, and finally delta x, the value of the function at x3. And then I can pull out the delta x, and we'd have this. So if you like, this is the formula for finding L4, isn't it? And if delta x changes value or the function is different, can you see that you could go through this and recalculate it? In this case, delta x is 0.5, and we're going to use those 4 numbers. So that's 9, 16.625, a 28, and a 43.875. Got my calculator. And I'll go 0.5 times, put a bracket around it, add those 4 guys together. And the answer I get is 28.75. Is there anything about that process that you're not sure about, or does it? It's easy to do, it just takes a while. That would be what I think. How's it look? Feel comfortable about it? No, I'm going to do this, but couldn't I give you another function, y equals sine x plus e to the x over x cubed, from 14 to 50 and ask you to do an L7 or something, would you be comfortable about how you would have to set the whole thing up? In other words, how do you get that table? Because once you've got that table, the rest is just number crunching, isn't it? Right? Once you know what these values are and the value of the function at these points, you're good to go. Oh, by the way, is this an under or overestimate again?
It's an underestimate.
Yeah, you see it in the visual? So isn't the true answer for the area under this curve, isn't this true answer a little bit bigger than that? We're not sure how much. Right? It could be, you know, 1 or 2, it could be 5 or 6, I guess. But we know it's definitely not going to be less than this, right? That's what the underestimate tells us. So I'm going to set up R4 in the same way, but R4 is going to use these 4 guys. Wherever you figure it out, the 4 on the right. And it's going to be delta X times this fella, plus delta X times this one, delta X times the third one, and lastly, delta X times the fourth one. And then we pull out the delta X's. We get that. And now we can put some numbers in. You wouldn't normally ever write this 2 things down. When you were doing your working, wouldn't you go straight from the table to this calculation? Right. I'm just showing you the kind of general way of how it's created. But your normal working would be this line, and then the answer. So in this case, 0.5 again, and 16.625 plus 28 plus 43.875 plus 65. Let's see what we get there. 0.5 times brackets 16.625 plus 28 plus 43.875 and finish with a 65. And the answer I get is 76.75. And we know that that's an overestimate. Now, I'm going to show you what, for some people, is a shortcut. And for other people, it's not worth the effort, so they just don't do it. When it's only 4 strips, it's probably not worth the effort. But if you're doing it with 10 strips, it can actually make your life a lot easier, right? So the shortcut I'm about to do is really better when you've got to do an L10 or an R10, right? Or an L8 and an R8, right? Really big, you know, lots of things have to be added, right? There is a way of going from this answer to that answer without doing this. Have you any idea what the trick is going to be? How do I get from this answer to that answer without having to recalculate everything from scratch?
Do you subtract 9 and then add 65?
That's exact. Subtract 9, gotcha, and add 65.
Yeah.
You are 99% there. And it might be 100%, it's just the way you've said it.
Half of 65?
Yes. So you subtract half of this guy and add half of that guy. So let's try it out. If what I said is correct, you take L4, which is this number, right? And you subtract this guy, right? 0.5 times 9. Now, by doing that, haven't you removed this guy's contribution to the answer? and then you add 0.5. I should have done it in the same way. So subtract 0.5 times 9, and then you add 0.5 times 65. See how that works? 28.75, take away 4.5, which is what that is, add 32.5. Let's screw that up. I wonder if I screwed this up. Interesting.
I think you calculated the L4 wrong.
Oh, this one wrong? Okay. What is L4?
48.75.
0.8875,
Yes, 48.75, correct? Is that what it should have been? Right. So if I make that 48.75, it did come out as the correct answer then.
No, you used the last data wrong.
The last data wrong.
Yeah, fx3
This one.
in L4. I think you
It
should
looks like
calculate
it's
the.
right. Oh, you mean when I
Yeah.
typed it in, I typed in a
Yeah.
different number. Yeah. But the final answer then would have been this number, correct?
You use the 43. When you use the 43, you enter the 3, not 43.
Okay. But 48.75 is the correct final answer if you fix that problem, correct? Yes, okay. Do you now know why I don't like numerical questions? I cannot count to save myself. Apart from the fact I cannot count, the process is correct. Okay, so you'll be much more careful about hitting buttons on calculators. And in this trick of taking away the first one and adding the second one is quite useful. Can we pretend, because I don't want to go through a huge 10 one, but let's suppose we had an L10 and an R10, right? And the L10 started with 0.2 and it was 14 and had a whole load of stuff, right? And the answer we got was 100 because I want to make my life easy. And for R10, it was 0.2, a whole load of stuff, and it finished with a 16, just for argument's sake. And that particular one, we did this one, and you wanted to get that one. Don't you basically just take this answer, remove this fella, which is what would that be? 2.8, and add that fella. So the net effect would be just to increase the area by an extra 0.4. So can you see that if I spend a lot of time on doing the left 10, can't I get the R10 with a lot less work, right? Just remove the 0.2 times the first one and add the 0.2 times the last one. And that reduces your workload a little bit. As I said, some people don't like it because it's too much hassle and they're not 100% sure what they're doing. And if that's the case, well, just be careful, as I wasn't, and make sure that you do these calculations as precisely as you can. Now, we are going to do a different version of that question. And I'm going to move over to the screen and we'll see one of these examples from the homework. Here is a decreasing function. It starts at 0. I believe it finishes at 10. Yeah. Read your answers from the graph, which is going to be a bit of a problem for me. And use 5 rectangles. Now, although you cannot see what I'm doing right now, I'm just writing it down. I'm writing n equals 10 down. How many strips did they want? Sorry, 5 strips. So I'm writing n equals 5 strips. A is the start, which is 0. B equals 10, and that makes delta x b take away a over n, and that basically tells us that x is 2. And maybe I shouldn't read things out. Let me show you what I've just done. From that question, I'm starting to create my table, right? 5 strips, start at 0, finish at 10. The widths are going to be 2. That means my table will look something like this. 0, 2, 4, 6, 8, and 10. Are you comfortable about how 5 strips starting here, finishing there, how we created this table? Because that's going to be the bit that you got to get right, or whatever else happens doesn't matter. It's not going to work. Starting at 0, going up in 2s. We good? Now, you're going to help me a lot here because I've only got one good eye and I'm not that good at estimating. Because in these questions, we don't have a function. All we got is this guy. So when x is 0, I don't think anybody's going to argue, would you agree it's 4? Now when x is 2, the answer is here. Now looking at the scale, that's 2, that's 3, that's 4. What do you want to go for? I think 2.4. Any disagreements? You want to go 3, 5, 2.4? Okay, you're not comfortable about it either. Okay, 2.4 it is. I'm just going to tell you what I think, and if you disagree, forget about it. I'm right. I'm calling the next one, which would be at 4. I'm going to call that guy, oh, darn it in space. I'm going to call it 2. Well, I'm going to call it 1.5. Right, x equals 6, which is here. I'm going to call that 1.9. At 8, I'm going to call it 0.6. And at 10, which would be here, I'm going to call it, I'm going to call it 0.3. Can you see the first problem that we've got is there is a bit of wiggle room in some of those answers. I know I never gave you the chance to disagree with me, but isn't there a chance that what I think is a 0.3 might be more likely a 0.4, you know, something like that. But you have to go with what you believe is correct. So can you imagine then that there's going to be a little bit of wiggle room in your answer? Because if you use a 0.4 instead of a 0.3, won't your answer at the end be a little bit different? I don't like questions where the scales are very hard to read. So I'm going to do this one using my numbers. And then I am going to go and check it on the WebAssign, and it's going to tell me I'm wrong. But if I read on, it says here, reading the values, 5 rectangles, a lower estimate. The function that we had looked like this. Would you agree it's decreasing? A lower estimate is just another name for an underestimate, okay? Is it an R4 or an R5 or an L5 that is going to do that? Which one is going to give me the underestimate? A left or a right? There's my little strip. There's a left. There's a right. Can you see?
Left is going to be overestimate, right? It's going to be underestimate.
Agreed, right? I mean, just draw a little baby picture and draw a little baby rectangle, and I think you can get it, right? doesn't need to be particularly accurate. So we've decided that since we're doing an underestimate and it's going to be 5 strips, we're going to get R5. So I guess I should write it over here. And we know that's going to be delta X, which is 2. And since I'm doing a right 5, doesn't it mean I'm going to be using the 5 of them on the right hand side? That's these 5, right? Correct. So it's going to be 2.4, 1.5, 1.9, 0.6, and 0.3. And I'm going to go, here goes 2.3.9, 4.9, 5.8, 6.4, 6.7.
I have a question.
Yes.
Okay, so for f at 6, wouldn't it be 0.9? Since the slope is
Did you
6%?
all catch that deliberate mistake? Okay. Nope. Told you I was just a second. 2.4, 3.9, 4.8, 5.6, 5.7. And that, thank you for catching that. That's 11.4. Okay, so I'm typing the answer in as we speak. Oh, let's show you. Yeah. Any gamblers amongst us? Do you think it's going to be correct? Oh, darn it, I don't. It's my version, not yours. I don't know then, is the short answer. If it wasn't correct, isn't it just maybe my 0.6 should have been a 0.5, and it's very frustrating and annoying, and I wish WebAssign was a human being, because if you were a human being, wouldn't you be able to look and say you were doing it the right way? We might argue over one of the value heights, but it's really just a judgment call. So you might get a little bit frustrated by that. Ah, someone has just gave us a clue. Thank you. Can you see the graph? Do you notice that all the numbers now have given me the coordinates that I need and some I don't? Oh, wait a minute. Can you see the graph? Right.
Yeah, in the
So
thing below.
let's see how good I was. 0 was 4. At 2, I had 2.4. At 4, I had 1.5. At 6, I had 0.9. At 8, oh, there's the one. At 8, I had 0.5. And 10, 0.3. So what I said about not worrying, getting worried by not getting the right answer has now gone away. You learn something new every day. So if you click on the picture, it actually gives you the coordinates. Oh, that is going to make these questions 10 times easier, isn't it? Because you just click on the picture and write the numbers that you need. It's obviously giving you more values than you're using, because I only used 2, 4, 6. I didn't use the 1, 3s and so on. Are we cool? Right. Now, if I wanted to do the next fella, which I will, which is going to be L5, I'm just going to jump to the working, because I now can see what the heck's going on. Let's see if I can get these guys going. And thank you from Eric. So it's going to be 2 times. It's going to be all these guys. So it's going to be 2 times. Oh, I'll do it from scratch. 2 times 4, add 2.4, add 1.5, add 0.9, and finish with 0.5. So that's going to be 2 lots of 6.4, 7.4, 7.9, 8.8, 9.3. And that gets me 18.6. So we know that is our underestimate. Or as they called it, lower estimate. And this is our overestimate. I believe they call it something like the upper estimate. Oops. So there's a new guy in town, which I'm now going to show you, which is it's going to be called M5. And this is called the midpoint. 5. Now what you do in the midpoint 5 is pretty much the same process, but you get your height. So if you imagine this is a piece of the curve and this is just one of my rectangles. And let's just say for argument, this is 2 and this is 4, right? If I was doing a left-hand side, wouldn't I be using the height here, right, at 2? If I was doing a right-hand side, I'd use this one up here, I'd use 4. But in a midpoint, you get the height by choosing the x coordinate, not at the beginning of the strip or at the end of the strip, but the x coordinate that's between these two, right in the middle of the strip. So it would be here. And if I guess it's getting very colourful here. Would you agree that in this particular picture, isn't the blue one an underestimate, the red one is an overestimate, and isn't that green one kind of better than both? Would you agree it's going to be more accurate? And can you see this green one? It's more accurate. If you think about it, isn't this little bit missing, but this little bit is extra? And aren't they very similar in shape? So probably quite similar in size. So they kind of balance each other out, don't they? The bit that's extra, you could cut it out and it would fill up most of the hole on the right. So if you had a choice between a left and a right and a middle, wouldn't you probably pick the middle if you only had one to do? Now, what about why do I even need the left and the right? Well, isn't the left and the right very often over and underestimates, but they put boundaries on it. But if you wanted to, you know, be a bit more accurate, wouldn't the mid one give you a little bit of a clue on something that's even closer to the right answer? So you might say that the answer is somewhere between 50 and 60, but my best guesstimate is 52. You know, so you know it's a little bit closer to the 50 side and not so close to the other side. Trying to sell you on this. Do you think the midpoint's worth doing? Right? It's going to get you an even better answer. So what that means is basically what we do is we set up a table. And the only major difference in this table is going to be the x coordinates. Now, remember the ones we did, it went 0, 2, 4, 6, 8, 10, and so on. So if this is 0 and this is 2, let's just look at the first 2 points. Can you see from that that the midpoint would have an x coordinate of 1? Are you happy about the first one? 0 to 2, the middle would be 1. Now, isn't delta x the same, right? The widths are going to be the same. So once I know the first one, don't I know all the others? Now, do you notice that when you do a midpoint table, you only have 5 values? You know, when you do this table, you always have 6 and you only use the first 5 or the last 5. But when you do a midpoint table, there is 5 in exactly 5. Now, this point, again, is in the cheat. That's 3.1. At 3, it's 1.9. At 5, it's 1.1. At 7, it's 0.7. And last but not least, at 9, it's 0.4. And if you want to do as we do here, you want to find midpoint 5 is going to be 2 times that guy plus that guy plus that guy plus this one, and finally finish with that one. 3.15, 6.1, 6.8, 7.2. And that gets us 14.4. So for that one shape that we were dealing with, we know that there's an underestimate of 11.4, there's an overestimate of 18.6, and our best guesstimate is it's about 14.4. So we've got a fair amount of, what should I say, information here about what we believe the true answer is. The true area is somewhere between 18.6 and 11.4, and our best estimate is that it's around 14.4. And that one question took about 15 minutes, so you're going to have a busy time. Is there anything about this process of, here is a graph, create these tables and use these tables to find left and right, create a slightly different looking table for midpoints and use it to get midpoint? We feel comfortable about that process? Good, because I don't want to do any more of those ones if I possibly can. So let's go and just do a quick scan at the homework questions and see if there's anything in there. And kind of hard to show here, but here's the original function. If you click on it, there's the numbers. That would have not been, that would be my first answer. One of these pictures would have represented it. Can you remember in this case, we did R5. So out of all these pictures, which one was using the right-hand side to get the height? It was going to be this one, isn't it? Would you agree this picture?
I can't see your screen.
Nobody can see my screen? Ouch. Let's try it again. There. So
It's back.
we got it now? Okay. So here is my first answer. It would go there. One of these 4 pictures would represent what that would look like if you drew it. Now, the first one we did was R5. So would you agree this picture here would be R5? Right. That one's got too many strips. That one's got too many strips. And isn't this one an L5? And then you do it again going the other way. And the other way, I believe, was 18.6. And if you do a left 5, I believe that's the picture. And then lower estimate, well, you just repeat yourself, 11.4. Upper estimate was 18.6.
That's for 10 strips.
Oh, darn it in space. Take it back. Moral of this story, read the question. I thought they were just asking you to repeat yourself. Okay, can you see that 10 strips is just going to be equally boring and equally long, times 2? And I've no idea what the answer is, so I'm going to pretend I do. You didn't know this, but that was 13, and this was 15. And if it is, that's a pure miracle. Right. Now, I would have liked this one, but it doesn't do it. But couldn't you also have midpoint 5 and you'd put the answer in there as well, and midpoint 10 and any other choice that we'd want? So can you see in question 2 is just do the same thing? Different curve, click on it, there's the numbers you need. But now they've gave you an M6. Right? So you do get to do midpoints as well. And which one of these gives the best answer? I can tell you right now, even though I've not done the question. Left, right, or mid 6. Which one typically gives you the most accurate answer?
Mid 6.
Mid 6. So even if you don't quite get these right, you know what you're going to get. And then we get the ones that I prefer, because at least now you can do as many strips as you want. There is a big drawback to drawings, right? Sketches. If I asked you to use that sketch and do 1,000 strips, I think your answer would be no, I'm not doing it. It'd be impossible, wouldn't it? Really physically impossible to do anything more than maybe 20 strips before it became ridiculous, right? So you're really only going to be limited to small numbers of strips. On the other hand, if you give me the function, can't you do the function theoretically, at least, with as many strips as you like? Because once you know the x coordinate, you know, 1.1, 1.2, 1.3, you can get the function, the height value at that point. And so that would be closer to what I did at the start of today. Remember the x cubed plus 1 question? This one would be very similar. And they give you some pictures and an over and an under. Well, we all know that 1 over x is a decreasing function, right? So if you're a decreasing function, won't the left-hand side be an overestimate and the right-hand side be an underestimate? And guess what? They're using the words I prefer. This question here has a video, so I think it's better to let you just watch it. But essentially, it's a waste of time, but you're doing it because they told you to. Here is a table where the numbers you're going to use. So you don't even need to create the table, right? They'll give you it. And then after giving you it, they say, nah, we don't like those numbers. You're going to change them by multiplying them by this fraction. And you get these numbers. And your job is just to fill in a couple of spare ones. And it's this table that you're going to use. And they kind of talk you through the whole process. Can you recognize that as basically delta x times the height, delta x times the height kind of thing? So, oops, where's it gone? Yeah. So that's basically the calculation, right? This fella is pretty similar to what I did at the start. Yeah, I probably should do one more of these just because I am skipping by a few. Oh, do you want me to do a question where you're given the function? God, it takes forever to scroll to the top of these questions. Yeah, like this. Or in, forget it, time. Okay, I'm going to talk it through because I don't have enough time. Let's talk through this fella. Here's your table with your numbers, right? It find a lower and an upper estimate. Okay. This table contains all the numbers I need. I just need to pull them out. Looking at this table, what's the delta? I guess I'll call it delta t now rather than delta x. What's the delta t using this table?
0.5.
Agreed? From 0 to 0.5 to 1 to 1.5. So won't you be going 0.5 times the height plus 0.5 times the height plus 0.5 times the height? Now, there is 1, 2, 3, 4, 5, 6, 7 numbers in this table, right? I am not going to get an L7 or an R7. Because there are 7 numbers, won't I be getting an L6 and an R6? So let's suppose I do the L6. See this guy here at the end? Him? Oops, try and hide him, that guy there. Don't use them. Won't you use all the numbers to the left? So it will be 0.5 times those guys there added up. Won't that give you a left 5? Now you want a right 5? Don't you go 0.5 and you add those guys up? And won't one of them be the underestimate and the other be the overestimate? Sorry for talking through that one, and hopefully tomorrow I'll actually physically do one. But do you get the gist of what you need to do when you're given a table? You basically just use all the numbers on the left except the last one, or all the numbers on the right except the first one. And those are the numbers that you're going to use to get left and right.